From now, we will study multiplication of two vectors. First is dot product, and the other is cross product. The dot product is projection operation, which can be used to obtain the magnitude of given field in a specific direction in space. A vector is given field and B vector is specific direction in space. So in other words, the meaning of dot product is contribution of A vector onto B vector. How much A vector contribute to B vector? This is the meaning of dot product. So we have two methods to calculate dot product. First is using geometric definition. The dot product of two vectors, A vector and B vector, can be defined as magnitude of A vector multiply magnitude of B vector multiply cosine theta AB. We have A vector and B vector, and theta AB is angle between A vector and B vector when initial point is matched. When initial point is matched, the theta AB, the length of A vector is amplitude of A vector. This is amplitude of B vector. A vector dot B vector defined as like this. How about dot product of unit vector in rectangular coordinate? As I said in the previous section, AX, AY, AZ vector is defined in rectangular coordinate X, Y, Z. AX vector is unit vector in X direction, and magnitude of AX vector is 1. AY vector is unit vector in Y direction, and amplitude of AY vector is 1. AZ vector is unit vector in Z direction. The magnitude of AZ vector is 1. So how about dot products of unit vector? How about dot products of same unit vector is magnitude of AX vector multiply magnitude of AX vector cosine theta. Magnitude of AX vector is 1 because AX vector is unit vector. This is 1. Theta equals 0. So this becomes 1. Similarly, AY dot AY, AZ dot AZ is 1. How about dot product of different unit vector? For example, AX dot AY is magnitude of AX multiply magnitude of AY cosine theta. The theta is pi over 2, so this is 0 because theta is pi over 2. So we conclude that dot product of same unit vector is 1 and dot product of different unit vector is 0. The second method is using operation definition. In geometric definition, it can be difficult to find the theta AB. So operational definition is easier to calculate of dot product of two vectors. Consider A vector is AX vector plus AY vector plus AZ vector. Consider B vector is BX vector plus BY vector and BZ vector. We try to calculate A vector dot B vector. A vector dot B vector is A vector is AX vector plus AY vector plus AZ vector dot B vector is BX vector plus BY vector plus BZ vector. Firstly, we multiply like this. So this is AX BX dot AX plus AY BY dot AY plus AX multiply BC. This is BC. AX vector dot AZ vector. Secondly, we can multiply like this. Plus AY BX AY vector dot AX vector plus AY BY AY vector dot AY vector plus AY BZ AY vector dot AZ vector plus lastly we can multiply like this. AZBX AZBX AX vector dot AZ vector dot AX vector dot AX vector plus AZBY AZ vector dot AY vector plus AZBC AZ vector dot AZ vector. So we have already known dot product of different unit vector is 0 and dot product of same unit vector is 1. Different unit vector dot product is 0, 0, 0, 0, 0, 0. So this is the dot product of same unit vector is 1. So this is AX BX plus AY BY plus AZ BZ. This is the dot product of A vector and B vector. So we try to study projection. We have two projections. One is scalar component projection and second is projection vector. The scalar component we have A vector and B vector. So contribution A vector onto B vector is length L. Length L is magnitude of A vector multiply cosine theta. We can multiply magnitude of B vector on both sides. Multiply magnitude of B vector is magnitude of A vector multiply magnitude of B vector multiply cosine theta. The right hand side is A vector dot B vector. So L is A vector dot B vector over magnitude of B vector. This is scalar component. This is scalar component. We have to understand this meaning. This meaning is contribution of A vector onto AX vector. Contribution of A vector onto AY vector. Contribution of A vector onto AZ vector. It means X components, Y components, Z components. The X component of A vector, Y component of A vector, Z component of A vector. This is the dot product's meaning is the component of some vectors. How about projection vector? We have A vector and B vector. The contribution of A vector is length L, and projection vector is not scalar L. This vector is projection vector. We express this projection A vector onto B vector. So this can be calculated L multiply AB. L is A vector dot B vector over magnitude of B vector. Unit vector of B vector is B vector over magnitude of B vector. This is A vector over dot B vector. The dot product result is scalar. Multiply B vector over amplitude of B vector square. This is a projection vector. So we take an example. A G vector is y ax vector minus 2.5x ay vector plus 3 az vector. Find the z vector at Q. So it means firstly we find position vector of Q is 4ax vector plus 5ay vector plus 2az vector. So G vector at RQ vector is G vector 4ax vector plus 5ay vector plus 2az vector. It means G vector at 4, 5, 2. 4 is x, 5 is y, 2 is z. Y is 5, so 5ax vector minus 2.5 multiply 4 is minus 10, ay vector plus 3az vector. This is the answer. And question 2 is find the scalar component. Scalar component z vector at Q in the direction of an vector at Q. So we have already known formula, and z vector dot an vector over magnitude of an vector. Since an vector is a unit vector, magnitude of an vector is 1. So this is g vector dot an vector. G vector at point Q is 5ax vector minus 10ay vector plus 3ag vector. So this is 5ax vector minus 10ay vector plus 3az vector dot 1 over 3 2ax vector plus ay vector minus 2az vector. We can calculate this. It becomes 1 over 3 and 5 multiply 2 is 10. Minus 10 multiply 1 is minus 10. 3 multiply minus 2 is minus 6. The answer is minus 2. The question 3 is vector component. Vector component G vector in the direction of an vector at Q. So we have already known for this formula, and this formula is z vector dot an vector multiply an vector over magnitude of an vector square. An vector is a unit vector. This denominator is 1, so this is z vector dot an vector multiply an vector. We have already known g vector dot an vector in question 2. This is minus 2, so the answer is minus 2 over 3 2ax vector plus ay vector minus 2az vector. This is the answer. The question 4 is find angle between z vector at Q and an vector this. We have already known z vector dot an vector is minus 2 equal magnitude of g vector multiply magnitude of an vector multiply cosine theta. The purpose is to find the cosine theta. So this is 1, and z vector is g vector at Q is 5ax vector and 5ax vector minus 10ay vector minus 10ay vector plus 3az vector and cosine theta. So minus 2 equal square root 5 square plus minus 10 square plus 3 square multiply cosine theta. This becomes square root 134. So cosine theta is minus 2 over square root 134. So theta is arc cosine minus 2 over square root 134 is 99.9 degree. This is the answer. Next question is the vertices of triangle point A, point B, point C. Vector projection. of RAB vector on RAC vector. This we have already known formula. RAB vector dot RAC vector multiply RAC vector over R magnitude of RAC vector square. So we find RAB vector and RAC vector. RAB vector is vector from point A to point B. This is position vector of position B minus position vector of point A. RB vector is minus 2AX vector plus 3AY vector, 3AY vector minus 4AZ vector minus RA vector is a 6AX vector minus AY vector plus 2AZ vector. It becomes minus 8AX vector plus 4AY vector minus 6AZ vector. RAC vector is AC vector is RC vector minus RA vector. RC vector is minus 3AX vector plus AY vector plus 5AZ vector minus RA vector is 6AX vector minus AY vector plus 2AZ vector. It becomes minus 9AX vector plus 2AY vector plus 3AZ vector. So we can find RAB vector dot RAC vector, RAB vector dot RAC vector. As minus 8 multiplied minus 9 is 72, and 4 multiplied 2 is plus 8, minus 6 multiplied 3 is minus 18. This is 62. We have also find RAC vector, magnitude of RAC vector. Magnitude of RAC vector square is minus 9 square plus 2 square plus 3 square. 81 plus 4 for 9 and 94. So the answer is 62 over 94. RAC vector is minus 9 AX vector plus 2 AY vector plus 3 AZ vector. This is the answer. This is the answer. So today we discussed about dot product and how to calculate dot product and what is the meaning of dot product. Thank you for watching this lecture and see you next time. Bye bye.